In previous lecture, I discussed sequence, arithmetic progression, geometry progression, and recurrence relation. Today, I will discuss some more example of recurrence relation. Example 3, let a n be a sequence that satisfy the recurrence relation a n equals to a n minus 1 minus a n minus 2 for n equals to 2, 3, 4 like this. And suppose that a0 equals to 3 and a1 equals to 5. What are A2 and A3? So A0 and A1 are the initial condition and we need to find A2 and A3. Here the recurrence relation is an equals to an minus 1 minus an minus 2. Now A2 will be A1, 2 minus 1, 1 minus A0 and A1 value is 5, A0 value is 3. So 5 minus 3 it will be 2. Now A3 will be A2 minus A1. A2 value is 2 is recently found and A1 is 5. So 2 minus 5 it will be minus 3. So we found A2 equals to 2 and A3 equals to minus 3. Here A0 and A1 are the initial condition. So the initial condition for a recursively defined sequence specified the term that precedes the first term where the recurrence relation take effect. So the first term that is given to apply on recurrence relation is called as initial condition. In this example, these are the initial condition. Now definition 5, it's about the Fibonacci sequence. So Fibonacci sequence are F0, F1, F2 like this is defined by the initial condition F0 equals to 0, F1 equals to 1 and recurrence relation f of n equals to f of n minus 1 plus f of n minus 2. Now for n, 2, 3, 4 like this we'll find. So here f of n equals to f of n minus 1 plus f of n minus 2. This is our recurrence relation. And initial condition is f of 0 equals to 0, f of 1 equals to 1. Now what will be f of 2? F of 2 will be f of 1 plus f of 0. So 1 plus 0 it will be 1. Now f of 3 will be f of 2 plus f of 1. So 1 plus 1 it will be 2. Now f of 4 will be f of 3, it's 2 plus f of 2. F of 2 is 1, 2 plus 1, 3. Now f of 5 will be f of 4, it is 3 plus f of 3. 3 plus 2 it will be 5. So these are the Fibonacci sequence. Here F0 and F1 are the initial condition and recurrence relation is f of n equals to f of n minus 1 plus f of n minus 2. And f of 6 will be f of 5 plus f of 4. F of 5 is 5, f of 4 is 3. So 5 plus 3 it will be 8. Here we got the sequence as 0 for f of 0, 1 for f of 1, 1 for f of 2, 2 for f of 3, then 3 for f of 4, 5 for f of 5 and 8 for f of 6. So this is the Fibonacci sequence. We have the recurrence relation and initial condition and we can find the Fibonacci sequence. When we solve a recurrence relation, we find the closed formula. So we say that we have solved the recurrence relation together with the initial condition when we find the explicit formula called as closed formula for the term of sequence. So let's see example of closed formula. Example 5, solve the recurrence relation and initial condition. Here recurrence relation is a of n equals to a of n minus 1 plus 3 for n 1, 2, 3 like this, and suppose a of 1 equals to 2. So initial condition is a of 1 equals to 2 and recurrence relation is a of n equals to a of n minus 1 plus 3. We can find closed formula in two ways. One is forward substitution, another is backward substitution. First I will apply the forward substitution. In forward substitution, we start with the initial condition and will reach till an. So here initial condition is a of 1 equals to 2. Now f2. A of 2 will be A of 1 plus 3. So 2 plus 3. A of 3 will be A of 2 plus 3. A of 2 is 2 plus 3 plus 3. It will be 2 plus 3 multiplication 2. Next A of 4. A of 4 will be A of 3 plus 3. And A of 3 is 2 plus 3 multiplication 2. So plus 3. It will be 2 plus 3 multiplication 3. So like this it will continue and finally will reach to A of n. And A of n will be A of n minus 1 plus 3, and A of n minus 1 equals to 2 plus 3 multiplication n minus 2 plus 3. So by simplifying we will get 2 plus 3 multiplication n minus 1, and this is our closed formula for this recurrence relation. A of n equals to A of n minus 1 plus 3. Now let's check the closed formula. Like A of 2 will be 2 plus 3 multiplication, its n is 2, so 2 minus 1, it's 5. Here we got A of 2 as 5. Now check A of 4. A of 4 will be 2 plus 3 multiplication, n is 4, 4 minus 1, it's 3. So 3 multiplication 3, 9 plus 2, it's 11. Now check A of 4, it's 11. So this is same. If we have the closed formula, we can direct substitute the n value and we can get the term of the sequence. This is one way of solving. It's forward substitution. Next I will solve by backward substitution. Means from an will go to initial condition, that is a1. So here an equals to an minus 1 plus 3. Now in place of an minus 1, we can write an minus 1 equals to an minus 2 plus 3. So in place of this an minus 1, we can substitute an minus 2 plus 3, and before 1, 3 was given. So after simplification, it will get an minus 2 plus 3 multiplication 2. Again, in place of this an minus 2, we can substitute an minus 3 plus 3. So after substitution, we'll get an minus 3 plus 3 plus 3 multiplication 2. So this 3 will add here, we'll get an minus 3 plus 3 multiplication 3. So like this it will continue. Finally we reach to a2. So it will be a2 plus 3 multiplication n minus 2. When it's 3, 3 multiplication 3. When it's 2, it's 3 multiplication 2. So here a2 plus 3 multiplication n minus 2. Again in place of a2 we can substitute a1 plus 3. So a1 plus 3 multiplication n minus 2. 3 will add with this, it will be 2 plus 3 multiplication n minus 1, and this is our closed formula. We can find closed formula by forward substitution, also by backward substitution. In algorithm we use the backward substitution, and here the process called as iteration. We have iterated or repeatedly used the recurrence relation, and we use two substitution. One is forward substitution, where we found successive term beginning with the initial condition and ending with an. And the second approach is backward substitution, where we start with an and we reduce to the initial term, that is a1. So as we begin with an and iterated to express it in term of following term of the sequence until we found in the term of a1. So it's called as backward substitution. We are going backward from an to a1. In case of forward substitution, we are going forward from a1 to an. Let's see another example. Example 6. Find the formula for the sequence with the following first 5 term. We have first 5 term, and from that we'll find formula for the sequence. Here the first sequence is 1, 1 divide 2, 1 divide 4, 1 divide 8, 1 divide 16. It's a JP. Here first term is 1, a equals to 1 and r equals to 1 divide 2. So every time we are multiplying by 1 divide 2. We can say the function is a of n equals to 1 divide 2 power n. For n0 it will be 1 divide 2 power 0. For n1 it will be 1 divide 2 power 1. For n2 it will be 1 divided 2 power 2. For n3 it will be 1 divided 2 power 3, like this. Next sequence, it's 1, 3, 5, 7, 9. It's a AP. First term is 1 and the difference is 2. So every time we are adding 2. 1 plus 2 equals to 3, 3 plus 2 equals to 5, 5 plus 2 equals to 7, 7 plus 2 equals to 9, like this. Here the function is a of n equals to 2n plus 1 and it's a arithmetic progression a equals to 1 and d equals to 2. Next sequence 1 minus 1, 1 minus 1, 1. So here it's a GP. First term is 1 and r equals to minus 1. Every time we are multiplying minus 1. So here the function is a of n equals to minus 1 power n. In today's lecture, I discussed some example of recurrence relation, Fibonacci sequence, and what is forward substitution and backward substitution. In next lecture, I will discuss some more example. If today's lecture is helpful for you, please like, share, and subscribe. Thank you. Bye bye.